This is the video for day 19 of summer school, June 23rd, 2020. Today we're going to learn about rules of exponents. We'll start with something familiar. 2 to the third power is 2 times 2 times 2, and that's 8. 2 to the second power is 2 times 2, and that's 4. 2 to the first power is 2, and now maybe you don't know what 2 to the 0 is. Let's use the existing pattern to try to figure out what that would be. What's happening here, if you look at the numbers, is that as you go down, every number is half of the number that was above it. 4 is half of 8. 2 is half of 4. That pattern continues and we just take half, then 2 to the 0 would be half of 2, 1. When we look at the division rules, you'll see there's another way to show that 2 to the 0 is 1. That's a very surprising result. When you were a little kid, you probably even imagined you could even take a number to the 0 power. Let's do something crazy. Let's just continue the pattern. If we take half of 1, then the next number must be 1/2. And if we take half of 1/2, the next number must be 1/4. And if we take half of that, we get 1/8. There is a connection going on here between the positive exponent and the negative exponent. The negative exponent is the reciprocal of the positive exponent. In other words, you flip it upside down. Reciprocal and reciprocal. So negative exponent means reciprocal. Two things we've learned so far. The 0 exponent is equal to 1, and negative exponents mean reciprocals. Let's look at a few examples and apply that. 0 to the 0 is undefined, but any other number to the 0 power is equal to 1. Example, 5 to the 0 is 1. X to the 0 is 1. Negative 7, notice the parentheses around the negative, is 1. Even a fraction, 1/4 to the 0 is 1. The answer is not 0. Do not multiply the base number with the exponent. It will not equal 0. That's a very common mistake. The next rule we learned was that any non-zero base number with a negative exponent equals the reciprocal of the base number, and the exponent turns positive. When you cross to the other side of the fraction, the exponent turns the opposite as well. So 2 to the negative 2, if I do the reciprocal, I get to write the exponent as positive. Here's what I like to imagine. If you see a negative exponent, it means that expression is on the wrong side of the fraction. Example B, x to the negative 7. We say fraction. Where's the fraction? Anything can always be written over 1. So there will always be a fraction there. X to the negative 7 over 1 means x to the negative 7 is on the wrong side of the fraction. What I should be doing is bringing it to the bottom. It becomes positive. But what would be there on the top? By the rule of reciprocal, the 1 that used to be on the bottom could go to the top. Or you could say there was always a 1 on the top. You could write this as 1 times x to the negative 7. So x to the negative 7 is leaving the top, but 1 is still there. It can happen with multiple variables in part C. 1 is still on top, A has moved to the bottom and now is positive, and B has moved to the bottom and now is positive. That just doesn't mean that when you see a negative exponent, you simply move everything to the bottom of the fraction. In example D, A is still positive, so we're going to leave A on the top of the fraction, but we're going to move B to the bottom and make it positive. We're going to move C to the bottom and make it positive. You ever seen West Side Story? You know that to be in a gang and to be on the wrong side of the railroad tracks at night is a problem. So basically, when you see that negative exponent, that means you're on the wrong side of the tracks. You're on the wrong side of the fraction bar. You need to go to the other side to be safe. So C. C is going to be going to the other side. Is it possible to be on the bottom of the fraction and be negative? Sure. We not only have a D that's a negative exponent, but we also have an F that's a negative exponent. So C squared, that's right where it should be. So it's going to stay on the top of the fraction. But F is to the negative 3, and it's on the bottom. So when we move it to the top of the fraction, it gets to be where it's supposed to be, and now we can write it as a positive. D is negative on top, so it gets to be on the bottom and gets to be written as a positive. That's how that works. If you cross the fraction bar line, the sign of the exponent changes. Anything positive stays where it is. Anything negative switches to the other side. So a to the third will stay where it is, but b to the negative 2 will switch to the other side as positive 2. C, negative, so now we put it on the bottom, positive. D, negative, we bring it up to the top, positive. F, negative, bring it up to the top, positive. G, positive, leave it where it is, and it stays the same. To divide a power having the same base, you subtract the exponents. First one, we'll do it the long way. When you say 6 to the 5th power, you mean 6, 6, 6, 6, 6. When you say 6 to the 4th power, you mean 6, 6, 6, 6. Start reducing. Reduce, 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 reduce. What's left, after all those turn into ones, a single 6 on the top. Could you have predicted that without having to do it the long way? That's the same as 6 to the 5 minus 4. You subtract the exponents when you divide, and so the answer is 6. And negative 5 to the 2, negative 5 to the 2, if I subtract negative 5 to the 0, but we learned that a number to the 0 power is a 1. Could we have figured that out a different way? Sure. If you have negative 5 squared, it means you have negative 5 twice. And negative 5 squared, again, is negative 5 twice. And if you start reducing, remember when you reduce, 1 replaces the number. So reduce becomes a 1, reduce becomes a 1, reduce becomes a 1, reduce becomes a 1. 1 times 1 over 1 times 1 is 1. What do we do with something like this in part C? What is our total nines on top of fractions? Remember, it's 9 to the 4th over 1. The total number of nines on top is 4 plus 2 is 6. And the total number of nines on the bottom is 7. What if we just subtracted 9 to the 6 minus 7, or 9 to the negative 1? Well, what do we say about negative exponents? Hey, you're on the wrong side of the fraction. Fraction being over 1. Really, the answer is 1 over 9. Here's another way to think about that. At this stage, just ask yourself, which is bigger, the bottom or the top? Oh, the bottom's bigger. You got 9 to the 7th. When you subtract 7 minus 6, just remember your answer should be on the bottom. It's the same thing in example D. Today's secret word is karate. I could say, okay, that's y to the 3 minus 5, and that's y to the negative 2. And then I remember, okay, negative exponent means I flip it to the bottom. That's one way to do it. Or the other way to do it is to look ahead of time and say, well, 5 is bigger than 3. So if I just put the answer on the bottom, I know it's going to be 5 minus 3. And that's 1 over y to the 2nd. Either way you want to look at it is fine. It takes you to the same place. Example E, sometimes you might have an expression where nothing simplifies, like x. There's no other x here, so x to the 3rd is just going to stay where it is. There's no other y. Y to the 2nd is going to stay where it is. But the z's, there's 4 z's on top and there's 5 z's on the bottom. So what I'd like you to do is think about if it was a z war. So if 4 z's on top of a fraction go to war against 5 z's on the bottom, and lots of people die in war, so this is going to cancel, 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 cancel. You can see the 1 is bigger is the one that's going to win. So because the 5 is bigger than the 4, you just do 5 minus 4 and then put the answer wherever there's more. There's more z's on the bottom. One more rule before we're done. The rule to simplify the power of a quotient, in other words, a fraction, what you do is you find the power of the numerator, that's the top of the fraction. Then you find the power of the denominator, that's the bottom of the fraction, and you divide. In A, 2/3 squared would be 2 to the 2nd over 3 to the 2nd. They both are going to get this 2. 2 to the 2nd is 4. 3 to the 2nd is 9. That's a reduced fraction. I can stop right there. We learned in the last lesson that when you take a negative to an odd power, the answer is negative. So there should be a negative there. 3 to the 3rd and y to the 2nd to the 3rd. So there's a negative out in front. 3 to the 3rd means 3 times 3 times 3. The answer is not 9. 3 times 3 times 3 is 27. And y to the second to the third power to a power, we learned this last time, power to a power, you multiply the exponents. That would be y to the sixth. Negative exponent on the outside. There are two ways to do this problem also. The most basic way is probably to do it this way. You're going to take the -2 exponent and you're going to bring it in here to both the numerator and the denominator. When you have a to the -3 to the -2, you multiply -3 times -2 and you get 6. Then you take b and you take it to the -2 power. Oh, but that means it's on the wrong side of the fraction. B to the -2 should really be on the top of the fraction. So a to the 6th, but when it moves to where it's supposed to be, to the top of the fraction, it becomes positive. Here's another way to think about this problem. Remember we said that negative exponents mean reciprocal? We could flip the fraction like this, and now we get to write it as a +2. Since negative exponents mean reciprocal. Well, we did the reciprocal. Then you have b to the second power over a to the -3 times 2, which is a to the -6. But a to the -6 is on the, you guessed it, wrong side of the fraction. So I bring it up to the top, and there's b to the second as well. See, same answer. I'm really just applying the rules in different orders, and you're allowed to do that. This is all taking place inside of the E. Let's look at a few of these examples. When you have numbers put in there, you put the numbers with the numbers, and the x's with the x's, and the y's with the y's, and the z's with the z's. So 2 times 3 is 6. Oh, there's a y to the 0. You know, that's a 1, so I can kind of ignore that. There's an x. Okay. We like to do these in alphabetical order. X, Y, Z, or A, B, C. There's a y to the -3. Oh, what does that mean? You're on the wrong side of the fraction. You're supposed to be on the bottom. And finally, there's a z to the second. And I just leave that on the top, and I am done. That's it. Everything gets the -3 power. This is one way to look at it. Everything gets the -3. So it's 2 to the -3. 0 times -3 is still 0, and x to the 0 is a 1, so I can really just ignore the x. And then y to the second to the -3, 2 times -3 is -6. Those negative exponents, what do they mean? It means you're on the wrong side of the fraction. So there's always a 1. So I could put a 1 in right here. There's no problem with that. So there's always going to be a 1 here. And then those are going to both go to the bottom. 2 to the third. Why don't we just put what 2 to the third is? It's 8. It's 2 times 2 times 2. Don't put 6. You're going to be tempted to put 6. But remember, with exponents, 2 times 2 is 4 times 2 is 8. 8y to the 6th. And there's my final answer. What we can do is we can do a little simplifying before we start. I do see that there's 2 z's here, so if I put those together, and let me alphabetize while I do that. I'll put the x's first, then, oh look, there's a couple of y's. There's y to the third and y to the third. That would be 3 plus 3, that's 6 y's. Y to the 6th, and then z to the 3, and if you don't see a number, an exponent, that's z to the 1. So it's 3 plus 1 is z to the 4th. But remember, this is all taking place inside of parentheses to the 4th power. So now everything inside of there is going to get the 4th power. So it's x to the second to the 4th is x to the 8th. Y to the 6th to the 4th is 6 times 4 is 24. And z to the 4th to the 4th is z to the 16th. You don't have to put 2 divided by 3 in the calculator. We're just going to leave those alone. And then look at the b's. Now if we did straight subtraction, it would be 2 minus 3. But let's be a little bit smarter about that. Where are there more b's? There are more b's in the bottom of the fraction. How many more in the bottom? There are 3 minus 2. There is 1 more in the bottom than there is in the top. So we're just going to leave that extra b in the bottom and call it a day. We're going to leave the 4 and the 3. Okay, you might get a little confused by the u's being -4 here, +4 here. If you ever get confused, remember, division is subtraction. We'll just go u to the -4 minus 4. See, there's a -4 on top, and you just subtract 4. The numbers will work themselves out. V to the 0 is 1, so I can kind of ignore that, and v to the second is positive, and it's on the bottom, so it really should stay on the bottom of the fraction. I'm going to just draw a little line here, put v to the second there. Now let's figure out what's happening with u's. You have u to the -4 minus 4. So just look at -4 minus 4, and that's -8. So it's 4u to the -8 over 3v squared. And then one more thing, right? This u to the -8 is on the wrong side of the fraction. Let's move it to the other side of the fraction. So 4 over 3, what comes first in the alphabet? U or v? T, U, V. Okay, so u comes first, u to the 8th, and v to the 2nd. If you do it alphabetical, you'll match the answers in the answer key every time. Okay, so the rest is for you. We have 12 more problems to do. Have the answer key. See you tomorrow.